Hello students, welcome to another video on the chapter Atomic Structure for Class 8 Chemistry. So before learning about the concept of atomic structure, I would like to tell you the history of atom. What is an atom? Atom is the smallest particle which you cannot see with your naked eyes. If you take a piece of gold and you keep breaking it, you will get the atoms of gold till the very end. Now, how was this discovery of the atom started? It actually started in India, where Maharishi Kanad, he proposed the matter consists of small indivisible particles called Paramanu, and which he called as a atom. And many of his predictions, which started many centuries later, many scientific experiments began after that. They gave different idea about the atom. Then came Democritus. He was a Greek philosopher and he told that everything is made up of minute particles called atoms. Now, these atoms were, according to him, the fundamental unit. And also, he called his theory as the theory of the universe because he told that everything is covered in the matter. Then came another English chemist, John Dalton, who in 1809 proposed the atomic theory. So the Dalton's atomic theory has certain postulates, like he said that all matter consists of small indivisible particles called the atoms. Atoms cannot be created nor destroyed. In chemical reactions, according to him, atoms are only rearranged, combined, or separated. And all the atoms of an element exhibit the identical properties. When elements react, their atoms combine in simple whole number ratios to form compounds. But later it was seen that most of his experimental observations could not answer many questions, and most of them were found to be just mere assumptions. Then came the discovery of the electron. In 1879, Sir William Crookes, he conducted some experiment in which he observed the electron. He performed experiments in a glass tube where air was removed. That was, it was a vacuum tube, also known as a discharge tube. He placed metal plates called the electrodes at both ends of the tube, and the negatively charged electrons were called the cathode, and the positively charged electrode was called the anode. It was seen that when a high voltage was applied across the tube, a beam flowed from the cathode to the anode, and this beam was called the cathode ray as it flowed from the cathode, and it was believed to contain the negatively charged particles. The cathode rays were not visible to the naked eyes, but it could be seen on a special screen called the phosphorescent screen. J.J. Thomson was the English physicist who also studied the properties of this cathode rays. He believed that the cathode rays always travel in straight line, and he proved this by showing an experiment where the beam cast the shadow of a fan placed in its path, suggesting that it is traveling in a straight line. The shadow was formed because the rays which were coming out of the cathode rays were traveling in a straight line. And this suggested to him that the cathode rays also contained particles which had some negative charge. When he placed the plates around this discharge tube or the tubes, the rays were deflected away from the negative because negative and negative will repel each other. Then the beam, as I told you, the beam casts the shadow of the fan. Also, the mass of this particle in the cathode ray was more than 1,000 times lighter than an hydrogen atom, it was found. And then Thomson predicted that these particles, he called them as corpuscles, very similar to the blood corpuscles that we have. And later it was renamed as electrons. And we can say that electrons were the first subatomic particles which were discovered. Then also the charge of an electron was measured by R. Millikan. He was another physicist, and he did some oil drop experiment, and he determined the charge of the electron to be around minus 1.60 into 10 to the power minus 19 coulomb. The symbol minus in front of 1.60 shows that negative part of an atom. Also, the mass of the electron was found to be 9.1 into 10 to the power minus 28 gram, which was very, very less as compared to the hydrogen's mass, and it was almost negligible. As you can see in this diagram about the cathode discharge tube with the cathode and the anode, positive and negative electrodes, and how the ray is traveling in a straight line. Here you can see when we keep the positive and the negative plate, the deflection is happening towards the positive, because definitely the negative and positive will try to attract each other, and that's why the deflection. Then came the plum pudding model of the atom. This was according to Thomson's discoveries. He told that the atom is like a sphere filled with a fluid of positive charge, and the negatively charged electrons were embedded in it. So his model resembled something like a pudding, which was all of positive charge, and the electrons being embedded in it as a plum. The discovery of the nucleus. Ernest Rutherford, he was a scientist from New Zealand who was awarded a Nobel Prize as well for his work in nuclear physics. He worked under the guidance of J.J. Thomson, and he did a very famous experiment, gold foil experiment. And Rutherford set up an experiment where positively charged particles were fired at a very thin gold film. As you can see in this diagram, there were some alpha particles which were fired into a very thin gold film foil in an evacuated chamber, and the circular fluorescent screen, as you can see here in the diagram, was placed behind the gold foil to detect the alpha particles, to see how they were traveling. And as you can see in this diagram also, that most of it were traveling straight, some were bouncing back, and some showed light deflection. So we can say that Rutherford observed most of the particles went through the foil in a straight line without showing any deflection, and very few particles were deflected at a very large angle. A small fraction of the particles were deflected from their path at small angles, and some particles even bounced. What was the conclusion drawn then from Rutherford's experiment? He concluded that a lot of space was empty in the atom, as alpha particles passed straight without any deflection. So there was no deflection, means it is empty. A positively charged mass in the atom caused some of the alpha particles to be deflected due to repulsion. So there is something positive, and the positive and positive particles which have been fired into the film gold foil showed that there is a deflection between the positive and positive charge. And as only a very few particles bounced back, the positively charged mass in the atom is very small, heavy, and is located somewhere at the center of each of the atom. He called this mass the nucleus. Sure, you have got some idea about the history of the atom, the electron, and the nucleus. If you have liked the video, don't forget to hit the like button and comment on it. Thank you for watching.